This is Robert. He works here. He's one of the friendly people that you can talk to.
Don't do it.
Give him a round of applause. He's talking about testing.
Thank you. Can you raise your hand if you can hear me? Does it work? Oh, it works. Okay. I've never spoken into a microphone before. Thanks for coming, and thanks for sticking around because you didn't have a chance to leave anyways. I wanted to talk today about testing because it's something that I spend half of my time doing, and I thought I would share with you why it makes me excited and why I think you should do it also. I'll have to unlock my speaker notes. Okay, so I hope if you are already writing unit tests in your life that this will rekindle that love, and if you're new to unit testing, I hope it will pique your interest to do it in the future. So my goals when I test, and what I think our goals should be, is one, that you would have this indication of whether it's okay to ship your code or not, whether it's the App Store or your web server. You just want to know if everything is working, and if you don't, and you're like me, you just lay awake at night like trying to remember what you did and whether you broke anything. The other thing is that if you work all day and you make something that's great, that's fine, but if the next day comes and you don't know what you did, or they fire you and hire another guy to do your job, then it doesn't really matter because no one knows. And some people document that, but you need to preserve this knowledge somehow. The other thing that I like to think that I'm going to need is that my application is going to grow over the next year or 2 years. And I want to set the stage for my application to grow. The other thing I want to do is that I hate fixing bugs, and I just want to write less bugs so I don't have to fix as many bugs. And then I want to make money, and these will all help me. I guess I get paid a salary. Don't tell Jeff. But so I wanted to introduce unit testing really quickly. And in case you're brand new, here's what I'm talking about. Unit testing is some code that runs your code and tells you if it works or not. The first part of this operation is called a fixture. That's where you set up some data. You say, I'm going to run a test using this kind of data. The next thing is the test case. This is where you use your code to set up whatever it is you're trying to figure out. Does this work or not? The last part is an assertion. After you've run your code a little bit, you want to check, did I get back the values that I expected? Did this write something to my database like I expect it to? And the last word I'm going to use is a test suite. That's all the tests that you wrote all together, running at the same time. That's all the tests that you wrote. So I thought I would give you an example. This is a class that I just wrote. It's called an addition. And it takes some inputs that are numbers, and it adds them all together and gives you a new number. I'm trying to break into the mental math as a service space. So if you're calculating a tip or something like that, we have a great service for you. When I wrote this class, I wanted to test it. So I wrote a test that looked like this. You can see it says class addition test, and it's extending mini test test. Oh, I should have warned you. Maybe you're already caught on. I'm a Ruby developer, so my tests are in Ruby. Sorry. Minitest is a Ruby testing library, and I promise your language has a testing library also. The first thing I did is I made some fixtures. So these numbers are the ones that I want to test with. The next thing I did was write a test case. Here's the code that I wrote before, and I'm not using it to make my customers happy. I'm using it just to test it. The last thing I did was make an assertion. So after using my test, I expect to get the sum of all these numbers, which is 6. I even wrote this out and ran it just to make sure it was right, and it was. An interesting thing about an assertion is it's different from raising an error. If my value doesn't equal 6, I'm going to get a test failure. And when you're testing, either you get a success, which means you got what you were expecting, or you get a failure, which means you didn't get what you were expecting. And then errors are yet another thing. Sometimes you get errors when you're testing, but that doesn't even mean your code is broken. It means your tests are broken. I don't know. So you get a failure there. And in the end, the way I see my tests is the code that I wrote, most of the day it's spending its time making customers happy, adding integers together. Or in my day job, I work on this app called Planning Center Check-ins, that if you're checking kids into an event, you're scanning stuff and printing labels and counting things. And it's successfully checking people in. But the other thing that my code does is it runs inside this test suite, and it hopefully prints out green success messages. And in the end, the code that I write has two purposes. One is to make the customer happy, and the other is to run in the test suite. So what's the point? If I don't get paid for making a test suite good, I get paid for making customers happy. But the thing that I like about testing is it gives you another angle to think about what you've done. Who are you really on the inside? I don't remember the context of that, but it came to my mind as I was doing this slide. I don't know. So early on when my startup was really getting off the ground, we really just had a very simple service that looked like this. There was one class called bad expression. I don't know why I called it that. But it took an operation name and some inputs. And if you look at that def value, the second big block down, you can see that it constructs a method name and then calls that method. And the class just had a bunch of different methods that did whatever it was the user wanted. So that was great. Then I started to write the tests for it, and I realized that as my service grows, this one test file is going to grow bigger and bigger. And I realized to myself, this class is too big. It's doing too many things. Maybe I can restructure my code so that the tests won't be such a pain. The other thing that I think about when I write my tests is I wrote a bunch of code. How do I know if it's working? That presents this separation between the interface of what you wrote and the implementation of what you wrote. On the one hand, the interface is how your code interacts with the outside world. So my interface with you is my clothing and my facial expression and my words. And then the implementation, that's how it works on the inside. You don't know if I've worn these clothes all week and I just always wear them. If I smile, you don't know if I'm nice or if I'm just containing my rage. And the idea in programming, is that the interface is everybody's business. I have to come to work in clothes, I have to smile. The implementation is my own business. If I don't want to wash my clothes, you can't tell me what to do. And as long as I smile, it's none of your business why. So the same thing is true for your code. And the thing about your tests is that you should only be testing the interface. My requirement as a society member is to wear clothes, and that's the only thing you can really expect of me. For this, I recently had a feature request in my startup. Some people wanted the largest even number for their collection of numbers, so I thought, okay, I'm going to write a largest even operation and get the largest even number out of it. So I wrote a test like this. You can see my fixture, my test case, and my assertion. And then I implemented it. I was pretty happy with this. We have this separate class for this operation. You can see the initialize method accepts some inputs. And in value, I take the inputs that I was given, and what's the word for that? I take the intersection of even numbers. So I thought of all the even numbers that I could think of and put them in this array, and then I sort of mask the inputs against those even numbers, and I take the biggest one that is from that overlap. And it was great. My tests passed, my customers were happy, revenue was growing. The problem is eventually someone reported an error that even though they had submitted 22, they didn't get that back as the largest number. So I realized that for some reason large numbers were failing. I don't know what it was. So I went back to the tests, and I wrote some new fixtures. I needed some large number examples, and I wrote a new test there at the bottom. Test result may be very large. And my test was failing. Now, one nice thing is because my tests were only testing this interface, they only tested that if you give some inputs in, you get an largest even number out. Oh, I updated one of those, but not the other. That one is wrong. Because I had only tested this interface, I was free to fiddle with the implementation. My customers had no idea that I had just thought of even numbers, and that's how I was doing it. So when the time came, I could refactor, and instead of using a list of even numbers, I could use the Ruby built-in even question mark method to determine which numbers were even and then get the maximum. So the advantage there was that the test was testing the external interface, and when bugs came, I was free to refactor the implementation. The other reason that I really like testing is because as your test suite grows, a new developer can step in, and if he or she needs to learn about your system, he can just read the tests and see how things are supposed to be used. Oh, I forgot this part is funny. The first one there, that was me like last month, and this is me now. I don't know what I was thinking. And that was also me last month, and this is our team now. So as you learn things and make things and have ideas, I think it's really important to record those in some sense, and your test suite is a really great opportunity for that. So in sum, I think that you should focus on having easy, fast tests, because the same things that make your tests easy and fast make your code good. Let's see, I have some things here. Oh yeah, let's say you want short, fast, readable tests. You don't want some one giant file growing like this. You want things broken up so that if you have to go learn something, you actually can. If you do that, you'll end up with your work being done in small units. Rather than one giant class, you'll have a bunch of little classes. Rather than one giant function, you have a bunch of little functions. That's good. As a result of doing that, instead of having one function that does the whole thing, each small part of that operation will be broken out. That gives you the freedom to change one and not worry about breaking the other one so much. I sleep better than that. If you strive to have comprehensive tests, that is to say, if the tests pass, my code is all working, you get some other benefits. You end up with this body of living documentation for a new team member or my older self who's trying to remember why we did it that way. Can we change it? Hopefully your thought process and your intent is visible in the way that you wrote the tests. And the end of it all is the idea that your system is known well enough that when it comes time to change it, you can do that confidently, knowing that you don't break other things. For me, that's most of the time I'm just changing the system that I wrote last month, and that's really important to me. Can I make this change and redeploy and not worry? Further reading. This guy, Kent Beck, he was a big fan of something called test-driven development. He says that he writes all of his tests before he even writes his code, and the reason for that is if you can write tests the way you think this thing should act, and then just write the code that makes it act that way, and it doesn't really, you test the interface, the implementation doesn't really matter. And you can also read about the test framework that's in the language that you like. Okay, that's the end.
All right, do any of you have any questions for Robert? Oh, whoa, you get lots of questions. Okay,
Really?
so I'm going to stop for a second. So we're, something funny happened? So we, for the first time, are actually streaming this. That's why we've been a little flustered with the microphones. It's a little, like, cumbersome, like, ugh. Anyway, so you guys ask a question, or you guys or gals ask a question, and I'm going to repeat it. I think we're going to try that.
Oh, yeah, that's good.
So it'll be like us having a conversation, but I'm just like a puppet for these people.
I
All right.
only speak through Chan. So.
Okay. I saw two hands. Yes. You.
So I actually have two questions. Well, I write lots of unit tests in the Java land. And
Okay.
the thing I always struggle with is how many assertions per test that I do.
Mm.
What's your opinion on how many assertions per test? Do you have one assertion per test? Do you do multiple
Oh.
tests?
All right. So I have two questions.
Oh, no. Oh, gosh.
I work mostly in the Java land, so so the question is, how many assertions per test should you do?
That's a great question. I think I don't care. I think if you have a lot of assertions, that's evidence that your code is doing a lot, right? And in the end of the day, hopefully your code does do a lot. And I think that's an example of your code being a mirror and saying, can't we separate this into two things? I think in the end of the day, of course, there's going to be code that does a lot of stuff, or you need to test it more than one way. But I certainly wouldn't recommend a hard rule, but fewer is better.
Cool.
So it depends.
Yeah.
Then the other question was, you said tests are equivalent with living documentation, but how much documentation do you put into the tests themselves to explain what you're testing?
Oh.
How much documentation do you put into the test themselves to explain what they're doing?
That's also a really good question. I hope none, right? I read somewhere that inline documentation is a code smell. Like if you have to document something, that's because your variables aren't named expressively, or your methods, or your classes, or your functions, or whatever. And I think the same goes for tests. My examples are, oh, this is going to take forever. My examples are, it's not up there anyways. Mini test, which gives you name the method after whatever it is you're testing. And all testing frameworks do that in some way, right? And I think that the goal should be to put whatever is in your brain into that name and then test it inside. Like you said, real life is trickier than a full stack presentation, so maybe you have to do it sometimes, and I definitely do.
Cool. And then one last question right here.
So I'm very naive when it comes to unit testing, but my view is that it's good for like libraries and things that have very sort of defined interface. But if you're testing, say, what you're going to put up on your website, is there good unit testing for that, or is that you use other tools for those kinds of
Ooh.
So the question is, so like for like testing your full like website, so what type of tests do you use to test like a full website, and does unit testing fit as that?
unit testing for that?
That's a good question, too. I think as much as you possibly can. I work in Ruby on Rails, which means there's a SQL database underneath and Ruby language on top and an HTML JavaScript interface at the very end. And I try to get as much testing as I can into the Ruby space. And the reason is because setting up a database takes a long time. And I think the reason I do that is because I feel really comfortable when I have as much code tested as possible. But you have to balance it against like how long is it going to take to run and how hard is it to write these tests. What was the question? Oh, testing your application. I test my application as much as I can because if I don't test it now, I'm going to have to fix it later. And I don't want to have to do that. So, is that a good question? I think you should write it for your application too, especially if you're going to have to maintain it, and especially if you're on a team with more people than your own brain who are going to have to maintain your code.
Cool. Everyone give Robert another round of applause. Awesome stuff, man.